Guys, today is March 20th. I'm a little bit late today, but let's start. Gonna do today's daily problem. Shoot. I don't know, sometimes it logs me out randomly. Okay, let's start. Find all possible recipes from given supplies. You have information about n different recipes. You are given a string array recipes and a 2D string array ingredients. The ith recipe has the name recipes I, and you can create it if you have all the needed ingredients from ingredients at I. A recipe can also be an ingredient for other recipes, i.e. ingredients I may contain a string that is in recipes. You are also given a string array supplies containing all the ingredients that you initially have, and you have an infinite supply of all of them. Return a list of all the recipes that you can create. You may return the answer in any order. Note that two recipes may contain each other in their ingredient. Okay. What? So to make bread, that's a recipe, right? Bread. You are given a string array recipes and a 2D string array ingredient. So we have yeast and flour. The ith recipe has the name recipes at I, yeah. You can create it if you have all the needed ingredients from ingredients at I. Oh, so this is the 0th recipe. Okay. Okay. So this is my recipes, and it's just a 1D, right? 1D array. The first thing in here is bread. So that's at index 0. And then we are also given some ingredients. And then the ingredients at the 0th is going to be a so we can create it. It needs a bunch of these. So this is at index 0, right? We're going to have like yeast or flour. And what it's saying is that since this is the index 0, in order to make bread, we need ingredients, yeast, and flour. We need all of these. And I guess supplies is what we have, right? You are given a string array supplies containing all the ingredients that you initially have. And you have an infinite supply of all of them. Okay. Return a list of all the recipes that you can create. Which, and the recipes are here, right? So supplies is yeast, flour, and corn, and all we need is yeast and flour, so therefore we can make bread. Okay, let me look at example 2. We have bread sandwich with the ingredients. To make bread, we need yeast and flour. And in order to make sandwich, we have bread and meat. Supplies is yeast, flour, and meat. Oh, that's interesting. So because we could create bread using yeast and flour, then we can create bread in our bread can be used to make sandwich. Um, a question I would have though is, does it have to be in this exact order? Like, what if I had it first? Uh, Something like this, would it still be okay? Let me just return empty string. Hmm. Without thinking too hard into it, it feels like originally I'm like, oh, we could probably just use like a hash map, which maybe we can, but now it's starting to feel almost like a graph problem, similar to like topological sort, right? Like there's a very specific order where um if our goal is to get to sandwich, we need bread and meat. We need to have bread and meat to get to sandwich, right? And then in order to get bread, we need yeast and flour. And if we are given these, right, yeast, flour, and meat, then we know that we can make bread and we can make sandwich. Yeah, so okay, I just need it. Okay, so it seems like those like topological sort problems. Um, and a good example of these are like those like course schedule problems. But I don't know if this is the correct approach right now, just because everything worked here, right? I need something that doesn't work. So maybe this one. Um, or let me think about it some more. Yeah, like actually that makes sense. I think we will use topological sort because let's just say that in order to make bread, you need yeast, flour, and eggs, let's just say, right? So I would have eggs right here. And let's just say this isn't part of my supplies. Then then bread will never be um, crossed off. If we do topological sort, it's like, oh, we don't need yeast anymore. We don't need flour, so we can slowly remove that from bread, right? So we don't need that. We don't need that, but we never have egg. So this will never finish. That will never finish. And then even though we could remove this, we can't make a sandwich either. So I'm going to try my own example where in order to make bread, we need yeast, flour, and egg. Yeast, flour, and egg, let's just say. And there's our supplies. I should expect no recipes to be made, right? Yeah, no recipes. Okay. Okay, so how would I do like a topological sort? I have to build this graph. So I think I just need to iterate. I would need an index, right, to iterate through recipes and ingredients. And then the ingredient will point to the recipe. So if this is bread, the ingredient is yeast, it will point to the bread. We're going to have flour, points to bread. And then we're also going to have egg, points to bread. Now for the next one, for sandwich, we're just going to create sandwich, bread. How do we know to use this one? Oh, it's not an actual node, right? They're just distinct by their names, so it should be fine, I think. Yeah, let me go ahead and start coding this. I think we could start coding it. Yeah, it's quite involved. Okay, so just a roadmap. I think I'm going to use topological sort, similar to like course schedule problems. We're going to have a index that starts at 0, and let's just do n is the length of recipes. How many recipes do we want to make? And I believe the recipes and the ingredients should have the same length, right? Yeah. Okay, so for I in range n, the current recipe is the recipes at I. Oh. Guess we don't need that. Oh, we do need some sort of graph, right? Graph default dict list. Okay, it's going to be a list. The key is the ingredient. Key is the ingredient. And what's the value? The value is the recipe, right? Yeah. So the current recipe is I, and then for ingredients at I, because there could be many ingredients, right? We want to do the graph at the ingredient dot append the current recipe. We need those ingredients in order to make the current recipe. We just do that for all of those. Let me print out the graph to make sure we're on the right track. Okay, so let's look at this one. Yeast points to bread, that's good. Flour points to bread as well. Egg points to bread. Bread points to sandwich. And then, oh, I had meat points to sandwich as well. Meat points to sandwich. I just didn't write that down. Okay, so that looks pretty good so far. That's exactly what we're expecting. Now, we just need to continue with topological sort. Okay. So, okay, so usually like with the class schedule stuff, we know that we could take all of, like, if these were the prerequisites, we know that we could take all of these ones. In this case, it's a little bit different, right? We don't know, even though these are all the ingredients that we need, we don't know if we have them. That's part of the supplies. So what we want to do is, maybe we could have like a queue, right? We could have some sort of queue. And then that queue is originally going to have all of the supplies that we are given. Yeah, so for S in supplies, Q append S. So for example, if we had yeast, yeast, flour, and meat. Let's just say we had yeast, flour, and meat as our supplies, right? That means we don't have egg. So everything underlined in blue are all of the supplies that we originally have. Now all we need to do is just do while Q. Wait. Sorry, I'm trying to think of topological sort as well. We could have an ins count. Which is a default dict int, and the key is gonna be the like recipe, let's just say, and the val is the how many ins it has, like the ins. So for bread, the ins count should be 3, right? Because there's 1 right here, 2 right here, and 3 right there. And then all I have to do is every single time I append an ingredient into the current recipe, all I have to do is say the ins count at this current recipe is equal to the length of ingredients at I. Cool. And let me print this out again. Sorry, I'm going kind of slow. I want to print out the graph. That's going to be helpful. Print out the ins count as well. So for the ins count, over here, we want bread to have 3, and we want sandwich to have 2. That makes sense, right? Because sandwich has 2 ins right there. Okay, I think that is perfect. So now that we have kept track of ins, we loop through supplies, add it to the queue. Now we can do while queue. And then what are we going to do? The current ingredient is equal to q.pop left. Now that ingredient points to, it could point to multiple recipes, right? So for recipe in graph at current ingredient, we want to remove it from the ins count, right? So the ins count at that recipe minus equal to 1. If ins count at that recipe is equal to 0, then that recipe can be made. So I definitely need to store some sort of result. Result.append that recipe. But that recipe might also be an ingredient to another recipe, right? So we need to add that recipe to our queue. Queue.append recipe. Okay, after all that is finished, I think we could just return the result. Let me go ahead and run this for now. Okay, that worked, and I'll submit. Awesome. Honestly, that problem felt pretty good. Not much to say about it. I mean, I'm a little bit slow. Obviously, like I'm not that good at this stuff, but I think it's very important if you don't know topological sort to study topological sort, because I think the rest is pretty clean code, right? Like we just need to create a graph, populate that graph. We want to keep track of how many ins there are, and then we just want to run like a BFS type thing on all the supplies. So if eggs was never part of our supplies, bread will never have finished because we will never have removed eggs from the bread count. Yeah, anyways, this is going to be, like linear? Linear time, linear space. And yeah. Cool. Hope you guys enjoyed and see you tomorrow.